I still have to download and upload and all the loads I have to do to get the video posted. So, no. So you can, it'll be a while. It'll be sometime this afternoon before I get that up. Because I can't.
Notes?
Yeah, the notes for today.
Okay.
I can't do it when I'm doing this, so. All right, so we'll just start at the top, I guess. All right, you tell me, that's a times right there. You tell me, what do I need to do first?
I don't really know. Do you move the 48 or the 3?
You move the 3. You got to get the 3. Okay, it's not. You're going to move it, but it's not going to be a subtraction. That's a times right there. So what do you have to do?
Oh, you're going to divide.
You're going to divide by it. Yes, you need to cancel the 3 out. So it's going to have to be a division. So we have 4 to the x plus 3 equal to 16.
Yep.
What's special about 16?
You can divide it with 4. Or it's the square root.
It's the square of 4. It's 4 squared.
Yeah,
yep.
It's the square of 4.
So we have 4 to the x plus 3 equal to 4 squared. We rewrote 16 as 4 squared.
Mm-hmm.
And now, when these two match, you can just set the exponents equal. So x plus 3 equals 2. You can't do that unless you have both of these are the same. Both of your bases are the same.
Okay.
Okay? So then you just solve. So x equals -1. Now, this is not a logarithm problem, so I'm not alarmed by the negative. My answer is just -1.
So for this, you just divide 9
Yep.
over.
Yep. Now over here in this last one, this is exactly the same kind of problem. But over here, you change 16 into 4 squared so that these two matched. So you're going to have to change something so that these match, because right now they don't match.
Can we put 1 over the 2?
Well, 2 to the first, like that?
Well, I was going to say it's a fraction, so they could be the same.
Well, okay, but
You cannot do that?
no, you can't just change a 2 into a 1/2.
Okay.
Let's look, I like the idea of recognizing there's a 1 there. Let's look over here. This is 1 over 2. Remember when you have 1 over, you have a negative exponent. So 1/2 is the same as 2 to the negative first.
Oh.
You need to remember that. Negative exponents mean 1 over. So the fact that I have a 1 over 2 means I really have 2 to a negative power.
Okay.
And now they match. So now I can say -3x plus 1. This is a multiplication here, so you have to distribute that negative. So it'll be -3x plus 1 equals 1. Your exponents are equal. There's a double exponent here, so you got to multiply them. So -3x equals, -3x equals 0. So x equals 0. So your answer is x equals 0. Yep.
What would you do for this next one?
Same thing. 9 and 27 can both be broken down into powers of the same number. So what's 9?
Would that be 3?
3 squared.
Or
So
yeah, 3
you can
squared.
think of 9 as 3 squared.
And would 27 be like 3 cubed?
Yep. And now they match.
Yeah.
So 2x equals 3, and x equals 3 halves. So all of those problems we were able to do without a calculator because we could always get a match here. So the next one, 4 to the x equals 7, you're not going to be able to get a match. So how do we solve something like that if we can't make them match?
Is this a log or
It
a
is.
problem?
It is. Which do you want to use? It really doesn't matter. Which you're most comfortable with.
Would it be ln?
You can ln. There's no benefit to ln'ing because there's no e to cancel out, but it's perfectly okay to ln.
Would you rather do a log
Doesn't matter.
on this kind of problem?
It's up to you. Whatever's going to make sense to you. It really doesn't matter.
The ln's fine.
Okay? And then the exponent comes out in front. And then we divide. So we have ln 7 over ln 4. ln 7, close parentheses, divided by ln 4. Do you have your calculator?
Not on me.
Oh, Isaac, you gotta bring it, okay? You gotta have it.
I'll have one for next class.
So it's 1.4037. Now, you don't have a calculator, but, okay, so I used LNs. Can you see?
Yeah.
Okay.
ln's a button on the calculator.
Yeah, what I mean is, you see that answer, all right. Now, I'm gonna pretend that I had logged both sides, used log. So then I would type log 7 divided by log 4. That would be the only difference. And I don't know if you can tell or not, but the answer is exactly the same. So when I told you it didn't matter, I was right. It doesn't matter. Now, I always use ln in E problems because it cancels out. It makes it easier.
Yeah.
But nothing's going to cancel here either way, so I'm just going to go ahead, ln, that made it difference, whatever. All right, next.
This is an E problem when you use log.
What? ln, you use E. Or E problems, you use ln. Yeah, ln is log base E.
Oh,
We're definitely going to use ln on this problem. This one didn't matter because it doesn't have anything special in it. This one has an E, so I'm definitely going to use ln. But what am I going to do first?
You can't break down the 17 or...
No, you can't. Yeah, so nope, what are you going to do first?
I'm not sure.
Oh my gosh, we've talked about this. Think for a minute. Think. What do
you would put ln down?
Well, let's do that. I just talked about this 10 minutes ago. If I put an ln on both sides, is anything going to cancel here?
No.
Because these are not next to each other. There's something in the way. So what do I need to do? Before I ln, what do I need to do?
Can you multiply?
By what?
The x?
No. You got to get rid of this 3.
Yeah.
You can't have that leading coefficient there. That has to be gone. So the first thing you're going to do is divide both sides by 3. Yes.
I was thinking that, but wouldn't that be improper fraction?
It doesn't matter.
Or,
We have a calculator, it doesn't matter. So e to the x equals 17/3.
okay, that makes sense.
You must get rid of the 3 because now when I ln both sides, what happens right here? What happens when you have an ln and an e right next to each other?
I can't remember.
Oh, Isaac, they cancel. Honey, you gotta pay attention and process some of this stuff. Because we've done about 1 million of those. When you have an ln and an e and they're touching each other, they cancel. That's why we use ln's in e problems. They cancel.
Why would they cancel?
They just do.
They just do.
They just do.
Okay.
Okay? Not going to go into a big long conversation about it. They just do. So you're left with x equal to ln 17/3.
Okay, that makes sense.
So then I go to my calculator and I type in ln 17 divided by 3. And that answer is 1.7346.
How are they doing on construction? I can hear it on the background.
Oh, it's just nonstop. Hopefully it'll be over soon, or at least the loud part will be over soon. The building won't be done for a while, but hopefully all that hammering will be done.
Okay, so you would subtract the 1 over.
Yes, good. That is exactly how you start. So you have 3 ln x equal to 9?
Yeah, and then you would divide that 3 over.
Yep. So you have ln x
3.
equal to 3.
ln x equals 3. The ln x doesn't cancel, does it?
There's no e.
Okay. Would you move the x over? Would you divide it?
Yeah, but you can't. When it's hooked to the logarithm like that, when it's the natural logarithm of x, you can't do that. What you need to remember is, and again, you need to remember this, when you want to get rid of a logarithm, because that's really what we want to do, is get rid of the ln, right? So we know what x is. To get rid of the logarithm, you must loop-de-loop.
Okay.
Okay? But when you loop-de-loop, you got to start with a base, and I don't have a base. There's no number right here. What is the number in an ln problem?
Is it 1?
No.
It's not 10, is it?
10 is the number if it said.
Is 10's the number for log?
Yes. If it said this, you would put a 10 in there. That's right. What do you put in there when it says ln? What number is ln connected with?
I can't remember.
Oh my gosh! E. The base of the natural logarithms is e.
I remembered log, I couldn't
Okay.
remember what ln was.
All right, you need to kind of go back and work through some of this stuff again because you got to remember it better. But here we go. So now I can loop-de-loop. I have e to the 3rd equals x, and that's actually your answer. You can stop right there. Oh shoot, no I can't, because it says round to the 10,000th. So I need to type that in on my calculator. And the way I type it in, and since you don't have a calculator, you better write this down. The way you type it in is you do second ln. Whoops, turn it on. So second, right here, the second button, second ln. And as soon as you hit that, an E pops up on the screen.
Okay.
And I want to raise it to the 3rd power, so I use that little button right there to raise. Whoops. Oh, I don't need to use that button because it's already there. So I'm gonna second ln, and it says what power do you want, and I need the third. So I'll just type 3, and the answer is 20.0855. So when you get your calculator, you're gonna wanna go back and make sure you can type those in and get those numbers.
Okay.
Because you need to be able
Yeah, I wrote
to
that
do
down
that.
on the homework.
Yeah, you need to be able to do that. All right, so now what I'm gonna do is I'm gonna give you a couple of separate problems, and I want you to work on them. All right, and then we'll come back together and check. All right, so I'm just making up random problems, so you'll just need a piece of paper somewhere to write these down. I'm gonna make up problems just like in the homework. Okay, so we'll start with, all right, I gotta plan this a little bit, so we'll start with, okay, so we'll start with that one. By the way, these two that we're getting ready to do are no calculator, okay? So
Yeah, I know
no
that.
calculator on these. We'll use a calculator for the other ones. All right, so try those two. You got them written down? I'm gonna go check something real quick. You got them written down?
Yeah.
Okay.
I have a question. So when you break down I divided the 2 and got 32. When it's just 8, 3x plus 4 equals 32. Can you do something with that 32 to make it equal to 8?
Not to make it equal to 8. You can break it down, but it's not gonna break down to 8. What common base do they have? See, 8 times 8.
Oh. I got it.
You got it?
Mm-hmm. Wait. Never mind. I thought it was going to be 8 to the power of something, but it can't. Well, 64 is 8 squared.
Okay, but the problem is, yes, you're exactly right. 64 is 8 squared, but you still have that 2 you gotta deal with, so that's really not a 64 anymore.
Yeah, it's
Yeah.
a 32.
Yeah, so we gotta figure out what to do with that. So let me help you. Okay. Let me show you here. So you knew you had to divide by 2. That's got to be the first step. I don't care what's going on. You got to divide by 2. Okay? Now, 32 is not 8 to a power. So you're not going to be able to use 8s. Okay, so what was another number you thought about?
4.
Is 8 a power of 4? So in other words,
No.
Can you make it? Yeah, no, you can't. So what's another one? Keep going down. Smaller yet.
Could it be 2?
Okay. 8 is 2 to what power? How many 2s?
Cubed?
Yep. So you have changed 8 into 2 cubed.
Okay.
Okay? Now, you got to be able to do the same thing with 32. How many 2s does it take to get 32?
Is it 4? No.
Figure it
I
out.
gotta think about it. There's 5.
Okay.
It's 2 to the 5th.
So now you've got both sides into 2s now. So you can set the exponents equal to each other. When there's a double, you multiply. So this is going to be 9x plus 12 equals 5. Right? Because we're multiplying, we're distributing.
Yeah.
So subtract 12, so 9x equals negative 7, and x equals negative 7/9. Now, I know that's negative, but don't worry about that. The only time we have to worry about the negatives is when we have a logarithm. If we don't have a logarithm, we don't have an issue. Okay? All right, what about this one?
You would make it, instead of 25, it would be 5 squared.
Yep.
Differences. And then you distribute that with the 3x plus 1.
Go ahead and work it out and tell me if you get what I got.
Yep, I got -3/2.
Okay. All right, so now let's do a couple calculator problems. You're going to need a well, you don't have a calculator, so you'll just have to get it set up for me. All right. What are you doing here with the first one?
You would put ln on them.
Right now?
So it would be ln 5e and ln 6.
Okay, now I want to talk about that for a minute, because if you do that, is this going to cancel? Are these canceling?
No.
Because they're not touching each other. There's something in the way.
Oh, the 5.
So what do I have to do?
Divide the 5 over.
You've got to divide the 5 over first, right. So e to the 7x equals 6/5.
And then it would be ln.
Now you can ln, right. And now, since the ln and the e are touching, they're gone.
Cancels.
So 7x equals ln 6/5.
Yep.
And all we have to do is take ln 6/5 and divide it by 7 to get our answer. So I'm going to give you the answer, but when you get a calculator, you have got to go back and practice typing that in.
I will.
Because if you miss all these problems because you know how to type it in, you will not get a good grade.
I do not.
So it
It's
should
just been
be
sitting there.
0.0260. 0.0260. All right, what about this one?
I'm gonna write this one down.
You should be writing them all down.
I am.
Okay. All right, you got it written down?
Yeah.
All right, take a minute and see what you can do. No, just be quiet. Take a minute and see what you can do. Okay? See how far you can get.
Okay, I made it. I have log 7 x plus 2 equals 4.
Okay, so the first thing you did, it sounds like, was subtract the 5, and then you divided by the 4. Absolutely perfect. Okay, now what do we do?
Do you loop-de-loop?
You absolutely do. You have a logarithm, and you need to get rid of it. So the only way to do that is to loop-de-loop it. So what's it going to be when I loop-de-loop it? What's it going to say?
What's the loop-de-loop like for these kind of problems? What's the...
It's always the same. Where do we start? What number do you start with?
Would you put the 4 as a power?
Yes. Power on what?
The x?
No, Isaac, have you slept through every class we've had in the last month? Buddy.
No.
7 to the 4th equals x plus 2. You start with the base.
Okay. I wasn't thinking you could move the 7, but okay.
You don't move it, you start with it. That's the number you start with. You're getting rid of the logarithm. So you take the base to the 4th power equals x plus 2. Now, this is a calculator problem. I don't know what 7 to the 4th is. So it's 2401. So 2401 equals x plus 2. So I'll subtract 2 and get 2399 as my final answer.
Can we do another one of those?
Okay, one more. And then you've got to go watch the notes after I get them uploaded. So one more. Here we go. Alright, so see if you can solve this one.
So on this one, I subtracted the 2 and divided the 3.
Okay, that's
So would
exactly.
you put lne down?
Okay, so wait, let me catch up here. Let me catch up.
7x
So
minus 1.
you did exactly the right thing, so let me go ahead and subtract 2 and divide by 3. So you are now at this point, right?
So would you cancel the ln out and then just do 7x plus 1 equals 2?
Oh, no. No. You can't just erase the logarithm. How did we get rid of the logarithm over here? This is a logarithm.
Loop-de-loop.
Exactly. What's my base?
E.
Uh-huh.
Oh,
So I'm
yeah,
going to
you can do that for
loop-de-loop.
E. I did.
So
I
e
got it.
to the second equals 7x plus 1.
Yep.
So I'll subtract 1 and divide by 7.
Yep.
And then if it's not a calculator problem, then I will just leave it like that. I mean, that's what it is. It's e squared minus 1 divided by 7. If it is a calculator problem, then I can type it in. And remember, to get e squared, I do second ln 2 minus 1 equals divided by 7. So when you practice this on your own, you should get 0.9127. When you practice typing that in.
Alrighty.
Now, what I would suggest you do is, you're already going to have some time wrapped up in the notes, at least the first part of the notes, but then I would suggest you take that homework that we just did, and you do it again on your own,
Okay.
making sure that you can remember the steps and all that stuff.
Yeah,
Okay.
I understand this. This helps a lot.
Okay. I'll see you. You can come back tomorrow if you want.
Alrighty.
All right.
I probably will for points.
All right. We'll see ya.
Alright, have a good day.
Bye.
You're welcome.